Okay, I'm going to review number 15 and then number 17 for you on the mass spring problems. These two are a little different. 16 is the same as 15, and then 18 is the same as 17. Okay, so for number 15, it says a mass of 1.4 kilograms is attached to a horizontal spring with a spring constant of 75 newtons per meter. So mass is 1.4 kilograms, right? Spring constant is K, is 75 newtons per meter. The spring is stretched from equilibrium by a position of 5 centimeters and released. So that means X equals 5 centimeters, which we want to change to meters. So it's 0.05 meters. Okay, so that's what they give us. What's the maximum elastic potential energy? So EPE equals 1/2 kx squared. Okay, so if EPE is 1/2 kx squared, we have k, we have x, we just plug in. So this is 1/2 of 75 times 0.05 squared, and then that is going to equal 0.9, 0.09, 3, let's just call it 0.94. We'll just do that. 0.94 joules. There's a point right there. Okay, so that's our EPE. Okay, what is the maximum kinetic energy? The maximum kinetic energy then will be the same. It'll come out to be the same value. We just have the EPE and the KE, right? They're switching forms back and forth. So if the maximum EPE is 0.94 joules, right, then, or 0.094, then this is just KE equals 0.094 joules. Okay, now it asks us what is the maximum speed of the mass. Okay, so now in order to solve for the speed, we know the kinetic energy. We can say KE equals 1/2 mv squared. Move that around and solve for V. So V equals the square root of 2KE over m. So this is the square root of 2 times 0.094 divided by the mass, which we have up here is 1.4 kilograms, and take the square root of all that. And I believe when I plug that into my calculator, I got 0.217 meters per second here for the velocity. I think that all just works out, right? So this is the maximum speed. And then the question is, at one point will the maximum speed be reached? The maximum speed occurs when the elastic potential energy is at a minimum, and that occurs at x equals 0. So this is just x equals 0, or at the equilibrium position, I guess you could say, right, at equilibrium. All right, so that's number 15. Now, number 17 is very similar. The only difference really here is that they start by giving us the information for the kinetic energy. The kinetic energy we start with. Okay, so again, we know that the mass here is 3.6 kilograms. They give us the spring constant K is 160 newtons per meter. And now the speed, right, V is 5.2 meters per second. All right, so what's the maximum kinetic energy? KE equals 1/2 mv squared, right? So this is 1/2 of 3.6 times 5.2 squared, right? So solving that out for kinetic energy, I get 48.7 joules. All right. So then, what is the total energy? Total energy is the same as the maximum kinetic energy, right? So the total energy would just be 48.7 joules. And then they ask us, what is the maximum elastic potential energy? Again, maximum EPE would occur when the kinetic energy is 0, so this is still 48.7 joules. All right, so now they ask, what is the maximum displacement? So here we're going to solve for x. Okay, and how do we solve for x? We solve for that with the elastic potential energy. I'm going to bring this right down here. So we have EPE equals 1/2 kx squared, right? Move it around and solve for x. So x equals 2 EPE, right, over k. And then we don't want to forget to take the square root of all that. So this is 2 times 48.7 divided by k, and they gave us that up here, 160. And again, don't forget to take the square root. And when I do all that, I get x equals 0.78 meters. Right, that would be 78 centimeters, but 0.78 meters. All right, now for part E, it says, make a sketch of the mass spring oscillating system and show maximum displacement, equilibrium point, and the energies related to these positions. Okay, I'm running out of room on my page, but I'm going to make this here my equilibrium position, which is x equals 0, right? And then it can go some distance here. We'll just call this positive amplitude, and then we'll make the same distance back here. Negative amplitude, I'll draw my spring in. All right, and then, right, those are our 3 positions. So this mass moves forward like this, right, and backwards like this. Okay, so let's call this location 1. At 1, the kinetic energy is 0. The EPE is maximum value, and in this case, the maximum EP is 48.7 joules. All right, at location 2, we switch. Now, the kinetic energy is a maximum value, again, 48.7 joules. All right, and now the EPE is 0. And certainly last but not least, right, location 3 here. And at 3, we're back to kinetic energy is 0, and EPE is a maximum value again. Okay, so I hope all that was helpful with solving your homework problems, and I think we'll just focus that in a little bit. Okay, great.